Is how we go through the paired TCR with the fax index sorted data. So you would actually upload your own fax index files. So we'll just go and find them in amongst the test data just to have a bit of a look. So for instance, with this particular data set, there were 3 different index files associated with the one plate. So this will automatically pair the right particular columns with our test data based on the group and the individual. And if there were multiple plates present, we can also add that individual in, and you just change this to either 1 or 2 depending on what you need. So, and then you can actually also change the file name. So that kind of summarizes how that gets paired with your initial clone count column with your final fax index data. So once you've downloaded all of those corresponding to your sheet, you copy and paste them together before we have to go through our data cleaning steps. Because the file's already been cleaned for the functional TCRs, what we want to do is some initial columns. So what we need to select is where the VG Jane selection is the CDR3 sequence, and then the second column. We also want to select every column in here except all the variable sequences, including all from the index sort, starting from the fax section. So the rest of them can be, except for well, because that will also fail. So, but we don't want the ones with the variable counts. So what this is doing in the background is grabbing and counting the amount of times a particular clonal sequences are observed from particular group columns or the individual dot group. It doesn't really, whatever your preference is for that. For this particular file type, we want to have all of them labeled. So see how it says all of my ones and then it says clonal. That's just saying that we've selected everything that's clonal. However, if I do a greater than 1, this will not label anything that was below 1 as being clonal. That's just to help with some of the coloring aspects. Some of the other things that are happening with this file is going on in the background. You can find some of the columns. As you can see here, these numbers have actually been converted from negative values into small integers to help with the plotting process. So it enables the conversion to a bi-exponential plot, which is needed. So we want to remove all the 0 values and we want to remove all the negative values so the plot can be generated. So lastly, we have generation of an index plot. So once we've gone and downloaded our final file, so which looks something like this, it's also in our test data. We can have a bit more of a look and interrogation of it. So some things have been labeled, some things have not. It just depends whether or not it's based on those cutoffs. So over here, what we want to do next is we've uploaded our variable file, our coloring file into TCR Explorer through here. You can change the font to whatever you like, depending on the journal preference. Just going through the panels, we can change all of our colors that are going on in the background. If we want to change how everything's being colored, we can go over here. Part of the reason I made those additional columns is so we can actually use them to select which ones are being colored. Next, we might want to go, or I just want to go for the default colors, or we might want to go with the random. You can also start changing the shapes however we like. There's also a panel over here that showcases what each of those values mean. So something like 85, you might want to pick use. You can fiddle with the sizes, so you can make that 10, 5, 1, 20. So just depending on how big and how small you want to make your data points. Over here, we've got some other features that can also customize this plot. We've got our X and Y intercept lines here. So for instance, this is more further over. So this is going to be about 2000. You can see how that moves up with the Y intercept by might be 3,000 might be a more accurate cutoff for these lines. We can also impact our X and Y axis, so we can make this 0.01, or we can make this, say, 100. So we can really zoom in on that particular section of interest. So as we can see here, with our lines, with the y-axis, we may only need to be about 4.5. So that kind of cuts, again, everything in. There's also opportunity to, let's remove our legend, but we may want to add histograms to have a better gauge on where the distribution of this data is based on these two particular tetramer stains. We can also start having a look then at not just which was the graph based in that particular paper, is we can start having a look at some of the other variables in there and how they're impacted by that. As we can see, these are CD3, CD4 positive cells, but they have relatively moderate expression of CD62, which is to be expected of this population. So these are good confirmations of what's going on. Can change the color to a dot. May want to make that orange. So it's up to you on how you decide to customize this plot. You can change the size of the text, the transparency of the points. So yeah, there's a lot of customizable features for this particular dot plot, so you can use that to also screen a multitude of different fluorochromes that you've included, or phenotyping markers. So it'll give you greater capacity to have an interrogation of those based on the single cell Sanger sequencing pipeline with corresponding FACS index data.